Imagine a day when forests on Earth simply disappear. No fires, no explosions, no sound of falling trees. Yesterday there were tropical jungles, boreal forests, and temperate woodlands. Today there is exposed ground, open land, and silence. This is not a dramatic fantasy, it is a thought experiment that helps us understand how deeply forests are woven into the system that supports life on this planet. In this video, we will look calmly and scientifically at what would happen to Earth if all forests vanished completely, how the atmosphere, climate, water, soil, ecosystems, and human life would change. To begin, it is important to clarify what we mean by forests. A forest is not just a collection of trees. It is a complex ecosystem made up of canopy layers, understory plants, mosses, fungi, insects, birds, mammals, and vast microbial communities living in the soil. Forests store carbon in wood and soil, regulate temperature, control water movement, and influence weather patterns on both local and continental scales. When forests disappear, all of these functions are removed at once. One of the first major changes occurs in the carbon cycle. Forests are among the largest carbon reservoirs on land. Carbon is stored in tree trunks, branches, roots, and in the organic matter within forest soils. When forests are gone, this reservoir no longer exists. Even if we imagine that trees vanish without burning or decomposing instantly, the effect remains profound. The planet loses one of its most important systems for removing carbon dioxide from the atmosphere through photosynthesis. Natural and human-related emissions continue, but one of the largest carbon sinks is suddenly absent. As a result, atmospheric carbon dioxide levels begin to rise more quickly over time. At this point, a common misconception needs to be addressed. Forests are often described as the primary source of oxygen on Earth. In reality, a large share of the planet's oxygen comes from oceanic microorganisms, and much of the oxygen produced by forests is consumed again through respiration and decomposition within the same ecosystem. The disappearance of forests would not cause immediate suffocation. Oxygen would remain breathable. However, the loss of forests would still profoundly alter the climate and the stability of life-supporting systems. Temperature regulation is another critical role forests play. Trees cool the land not only by providing shade, but through a process called transpiration. Water absorbed by roots is released into the atmosphere through leaves, and this evaporation removes heat from the surface. Without forests, transpiration drops sharply. Land surfaces heat up more during the day and cool more rapidly at night. Temperature extremes become more common, and many regions experience hotter summers and more unstable daily temperature swings. Surface reflectivity also changes. Forests are dark and absorb sunlight, while bare land or grass reflects more light. At first glance, higher reflectivity might seem like it would cool the planet. But in most forested regions, especially in the tropics and temperate zones, the cooling lost through reduced evaporation outweighs this effect. The result is a net increase in temperature and drier conditions. The water cycle undergoes a dramatic transformation. Forests act like vast biological pumps, recycling moisture back into the atmosphere. Water evaporated from leaves contributes to cloud formation and rainfall, often far inland from the oceans. Without forests, continents lose this internal recycling system. Rainfall decreases in many regions, wet seasons become shorter, and droughts become more frequent and prolonged. Paradoxically, floods may also become more destructive. Forest soil absorbs rainfall gradually, slowing runoff and stabilizing river flow. When trees and undergrowth are gone, rainwater rushes over the surface instead of soaking into the ground. Rivers rise rapidly during storms, causing sudden floods, and then drop to very low levels during dry periods. This creates a pattern of extremes, violent flooding followed by severe water shortages. Soil is one of the first components of the environment to visibly deteriorate. Tree roots hold soil in place, while leaf litter feeds microorganisms that build fertile ground. Without forests, soil becomes exposed to wind and rain. Erosion accelerates. The thin, nutrient-rich topsoil is washed into rivers or carried away as dust. What remains is compacted, dry, and far less capable of supporting plant life. Once topsoil is lost, recovery takes decades or centuries, if it happens at all. As erosion intensifies, a feedback loop begins. Poor soil supports fewer plants, which leads to even greater erosion. Large regions transition into degraded landscapes resembling semi-deserts. Dust storms become more common, transporting fine particles across continents and further disrupting climate and ecosystems. The impact on biodiversity is severe. Forests are the most biologically rich ecosystems on land. Tropical forests alone contain a large fraction of all known species. When forests vanish, countless species lose their habitats immediately. Many cannot migrate or adapt fast enough. This leads to one of the largest mass extinctions in Earth's history. The loss includes not only large animals, but insects, fungi, plants, and microorganisms that perform essential ecological functions such as pollination, decomposition, and soil regeneration. Food webs collapse as vegetation disappears. Herbivores lose their food sources, predators lose prey, and complex ecological networks simplify into far less resilient systems. A simpler biosphere may survive, but it is far less stable and far less productive. Human societies are affected indirectly but profoundly. Forests regulate rainfall patterns that agriculture depends on. Without them, crop yields become unpredictable. Heat stress increases, soils degrade, and irrigation becomes more difficult as water sources shrink or fluctuate. Food production declines in many regions, especially those already vulnerable to climate variability. Cities experience intensified heat, poorer air quality, and water management challenges. Without nearby forests, urban areas lose natural cooling and filtration systems. Dust and pollutants become more concentrated. Water treatment becomes more expensive as rivers carry more sediment and contaminants during floods and become stagnant during droughts. Over decades, the planet does not die, but it settles into a new equilibrium. Continents become drier, temperature extremes intensify, and ecosystems grow simpler. Some vegetation may return in the form of grasses or shrubs adapted to harsh conditions, but complex forest ecosystems are extremely difficult to rebuild. Once climate patterns and soils cross certain thresholds, natural recovery becomes slow and uncertain. One of the most important scientific conclusions is this: forests do not merely exist within a climate, they actively shape it. When forests disappear, the Earth system can cross tipping points where returning to previous conditions becomes unlikely, even if the original cause is removed. In summary, the disappearance of all forests would not end life instantly, but it would fundamentally alter the planet. Carbon dioxide levels would rise, temperatures would increase, water cycles would destabilize, soils would erode, biodiversity would collapse. Human life would become more difficult, less predictable, and more fragile. If you are interested in understanding how Earth works as a connected system, And what happens when one of its key components disappears? Consider subscribing to the channel. In future videos, we will explore what happens if all glaciers melt, how the planet changes without polar ice, and why ocean currents shape the climate of entire continents.